So looking at number 3 of the free response, topic 2, the figure shows the graph of the piecewise linear function f. Okay, so this is the graph of f. This isn't f prime, this is f. For -4 to 12, the function, I like recording what time we start to see if it indeed takes 15 minutes. The function is defined by, the function g is defined by the integral from 2 to x of f of t dt. So like a little note to self, that means area under f from 2 to x. Area under this graph starting at 2 and moving forward, maybe backwards, but 2 to x. Okay, does g have a relative minimum, a relative maximum, or neither at x equals 10? Okay, the g. Well, let's see. A relative max or min or neither? G has a relative max when g prime changes positive to negative, and a relative min when g prime changes negative to positive. Again, I like justifying the answer first because then I know what I'm looking for. Okay, at x equals 10. Well, hold on. We need to know something about g prime. Well, if g equals the integral from 2 to x f of t dt, and I want g prime, then I need to take a derivative of both sides. To get to g prime. So what's the derivative of the right-hand side? What's the derivative of the integral of f? Just f. So that seems like a pretty big deal. I bet I used that more than once in this problem. So g prime is equal to f. So I'm looking to see if f changes plus to minus or minus to plus at x equals 10. So at x equals 10, g prime well, it's at 0, but it doesn't change signs there. Does not change signs. So not a relative min or max. So kind of the key part of that problem was knowing that the derivative of an integral gets you right back to the original. Part B. Does the graph of g have a point of inflection at x equals 4? Justify your answer. Let's see. G has a POI if. What's the rest of that statement? How do I know if G has a point of inflection? Yes, something about double prime.
Oh, okay. But I don't know what.
You don't know why. Okay, so you're on the right track.
G double prime, which is F prime? Or
Yep, G double prime, which is F prime. That's true.
Changes negative to positive. Right? No, it's...
It doesn't matter which way it changes. Yeah, as long as it changes. So this is a little bit like there's this parallel stuff between the first derivative and the second derivative. But with the first derivative, there's specific names for which sign change happens, like plus to minus versus minus to plus. With the second derivative, if it changes signs, there's not specific names for which way it changes. It's just, it's a point of inflection if G double prime changes signs. But G double prime is F prime. So at x equals 4, let's see, G prime is F prime, which is the slope of F you want to like explain what we're looking at on the graph. At x equals 4, what's happening to f? Good way to say it. At x equals 4, f prime changes. We could just say changes signs, but we could be more specific. Changes from positive to negative. So, and we've already said that f prime and g double prime are the same thing, so we don't have to keep like repeating the fact that they're the same thing. If you need to like convince yourself, that's fine. But we've already made the claim or stated that they're equal, so I don't have to. This means the grader can use them interchangeably now because you've stated it. So g has a point of inflection at x equals 4. Okay, so far so good on this one. So not bad. Remember, there are 9 points apiece, and you try to get all the points you can. Usually, hopefully, some of the points are easy and some of them are a little bit more difficult. Find the absolute minimum. Absolute minimum, I'm thinking about check endpoints when I see the word absolute. And the absolute maximum. So absolute means I should probably check them in a table to make sure I find everything. The value of g on the interval -4 to 12. Justify your answers. Okay, so justify your answers. A table of value is justifying my answers. So I need x and g of x. And I know I need to check -4 and 12. And then I need to check any critical points. Critical points of g. Or I could phrase it this way. I need to check any possible mins and maxes. So that would be where g prime changes signs. Because if g prime changes signs, that means I've got a relative max or maybe a relative min. But we said earlier that g prime was equal to f. So g prime changes signs, f changes signs at x equals -2. Where else does it change signs? Where else? And 6. It hits 0 other places, but it goes to 0, but then it goes back to increasing. So that's 2 is not going to be a min or a max. Same with 10. So I need to check -2 and 6 and the endpoints. And I can tell by looking that -2, let's see, that means, I'm going to just relabel my graph, g prime, changes from negative to positive. So -2 is at the least a relative minimum, and 6 a relative maximum. All right, back up. What are we looking for? Find the absolute minimum value and the absolute maximum value of g on the interval. Okay, I'm set up. When I find these values, what's my answer going to be? The x value or the y value? Which one? I think you're right.
Y?
The y values. So I need to plug all these in and see what I get for the y value. So g of x is the integral from 2 to x f of t dt. I guess we'll start with -4. I kind of don't like that. What's weird about that? Switch them, yeah. If you switch them, what's the price you pay? The negative. So I'm fine with switching them. I would switch them as well. So let's go from -2 to 2. So the area under the curve. You know what? Maybe wise to label all these areas right now. They're all triangles, so it shouldn't be too bad. 1/2 base times height. So 4 times 2 is 8. Divided by 2 is 4. But it's below the axis, so it's going to be negative. Then I'm going to catch all of this triangle. So 4 times 4 is 16. Divided by 2 is 8. This triangle is the same size, so that's 8. This triangle is the same size, so that's -8. And then that last triangle is half of that, so -4. Okay, so from -4 to 2, -4 to 2, I've got -4 plus 8 with the negative out front. Let's be careful here. 8 minus 4 is 4, but a negative on there gets me -4. Alright, the integral from 2 to -2.
Where did you get the 8
from? I'm looking, I want the area from -4 to 2.
Oh, from 2. Never mind.
Got it?
Yes.
Okay. On the second one, I want the area from, well, they're backwards again. The area from -2 to 2. Let me see my work and my picture at the same time. So from -2 to 2 would just be 8, but there's a negative on there. So -8. Which, so far this is making sense, right? This point is supposed to at least be a relative minimum, so we went down to get there. We should be going up to get to 6. So the integral from 2 to 6. F of t dt. No switching here. The integral from 2 to 6. The area under the curve from 2 to 6 is 8. And then lastly, the integral from 2 to 12. 2 to 12 is 8 minus 8 minus 4. Why do we do this? What was the question? The absolute minimum and the absolute maximum value. So the absolute minimum is -8. It occurs at x equals -2, but you don't have to say that. The justification is all your work. And the absolute maximum is 8 at x equals 6. Honestly, I'm a little surprised that one of them didn't occur at an endpoint, but because they said absolute and justify your answer, they will be looking to see that you check the endpoints. But I'm a little surprised one of them didn't turn out to be an endpoint, just to kind of prove the point. All right, that was C. Now, part D. Find all intervals for which g of x is less than 0. Wait, I think what we just did might help. G of x is less than 0. Oh, this is going to be a little bit trickier. So it changes somewhere between -2 and 6. Let's see. What's the easiest way to do this? Well, I know that, to add to my table here, I know that g of 2 is 0. Because, how do I know that? How do I know that g of 2 is 0? From 2 to 2. So I think I can see, because I've got all my critical points, so it doesn't change directions in here anywhere. So it's negative from, that means it's negative, g is negative from negative 4 to 2. So from negative 4 to 2. And let's see, what else? Somewhere between 6 and 12 it flips over. This is a tricky one. So I want to know where it's equal to 0 in there. But I start here. It's a very conceptual problem here. So if I start at 2, moving forward, so I'm adding area. So I add 8, I subtract 8. So that means at x equals 10, we're at 0. G is 0. Because from 2 to 6 is a plus 8, and then from 6 to 10 is a minus 8, and then we subtract some more. So at x equals 10, we have another 0. So that means from 10 to 12, g is less than 0. And it didn't really say justify your answers, it just said find them. So we're good there. $7.53. So that took 18 minutes. But again, that's me slowing down, drawing pictures, trying to explain along the way. Yeah, D was kind of tricky. I'm trying to think what the point values might be, because it has to add up to 9. So A is probably just 2 for the answer and the justify. B is probably 2. Does it have a point of inflection? Justify. C is probably 3 points, because there was a whole lot to that. We had to do a table, then we had to pick the right min and max. So I bet 3 was worth 2, and D was worth, I bet part C was worth 3 and D was worth 2. I don't know that, but that's just my guess. And you should not spend any time thinking about that on the test. But if D seemed crazy, like sometimes that happens, like the first 2 or 3, you're like, it's not a big deal, I got that. And then you hit the last one, like, what is going on? Well, they've got to have questions on there that separate the 4s from the 5s. So if you get stuck on the 4 to 5 question, no big deal. Leave it and come back to it. Don't spend forever on that. Especially if you feel like you got most of the points on that. Right? If you get a 7 out of 9 on all of them, you're on track for a 5. So good work. All right, let's look at the multiple choice for today.